to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So for today's knowledge area, we'll be focusing on mechanics, which has a total of 93 marks. That is according to your examination guidelines, and mechanics is under your paper 1. And for today's topic, our focus area will be on Newton's laws, and of which Newton's laws in terms of paper 1 is going to be under question 2, and it consists of plus minus 21 marks. Okay. So when it comes to the mark allocation of paper 1, we have section A, which has 10 multiple choice questions, and it consists of 20 marks. Then again, we have your section B, which consists of structured or long questions, and it consists of 122 marks. Now for paper 1, we have a total of 150 marks, and the duration for the paper will then be 3 hours. Okay. Then the topics to be covered in terms of paper 1 will be mechanics, which consists of 93 marks, that is according to your examination guidelines, and mechanics has a percentage weighting of 62%. Next, we have your electricity and magnetism, which has 33 marks, and it consists of a percentage weighting of 22%. Next, we have your wave, sound, and light, and it consists of 24 marks with a percentage weighting of 16%. Okay, then the topics to be covered, that is in terms of paper 1. So that is up until the end of the year will be your mechanics, which has 93 marks. And under mechanics, as I have already stated, our focus will be on Newton's laws. Then later on in the year, we are then going to focus on your momentum and impulse, and work, energy and power, elasticity, hydraulics, and also viscosity. Then we also have your waves and sound, which has a total of 24 marks. And we also have your electromagnetic radiation. So learners, if you have any questions, we have a WhatsApp number. So you are reminded to please send us a WhatsApp on 063 508 1301. I'm going to repeat that. So if you have any questions, please send us a WhatsApp message on 063 508 1301. Okay, so let us continue. Then in terms of your electricity and magnetism, we have a total of 33 marks, which consists of electrostatics, electromagnetism, and also your electric circuits. Okay, then in order for you to prepare for your examinations, you are going to need to use your examination guideline. And in terms of the examination guideline, it says here Newton's laws and the application of Newton's laws. So for now, I'm not going to go through all the points on the examination guideline. What we are going to do is that as we continue with the lesson, we are going to unpack each point in terms of the examination guideline. So just to read the main headings here in terms of the examination guideline, it says that you are required to know the different kinds of forces. That is your weight, your normal force, your frictional force, your applied force. That is then your push or your pulling force. You are also required to know your tension, which then talks about your strings and your cables. Next, on the examination guideline, you are required to know about your force diagrams and your free body diagrams. So as I've already previously stated, we are going to unpack all of these points in detail as we continue with the lesson. Again, in terms of the examination guideline, you are required to know Newton's first law, Newton's second law, and Newton's third law. Okay, and on this page here, the laws are then in continuation. Okay, then when it comes to Newton's law of motion, it is divided into 3 laws. So we firstly have Newton's first law, which consists of inertia and mass. Then secondly, we then have Newton's second law, which then consists of free body and force diagrams, and which also consists of your acceleration. Then lastly, in terms of Newton's laws, we have Newton's third law, which then consists of your action-reaction pairs. So this is our definition of Newton's laws and Newton's first law, and it comes from the examination guideline. So remember, learners, that whenever you are stating the definition, it needs to be a copy and paste from your examination guideline. So Newton's first law states that an object continues in a state of rest or uniform, moving with a constant velocity, unless it is acted upon by a net or resultant force. Okay, so let us now unpack the definition of Newton's first law. What does it say? It states that an object, so let's say that you have an object, maybe let's say you have that object, for example, it could be a box. So any object that you can think of, it could be a box. In this case, I'm going to use a box. It says this object will continue in a state of rest. So if an object continues in a state of rest, what does that mean? It means that the object does not have a velocity. It means that the object is not in motion. So if this box here is not in motion, this box is going to continue to be what? To be at rest. That means what? It's going to continue not to be in motion, okay? Or unless it is acted upon by a net or a resultant force. So we are saying that if this object is at rest, meaning if this object is not in motion, meaning if this object does not have a velocity, that object is going to continue to be at rest unless we have a net or a resultant force. So unless we have some kind of force that is going to push the object so that the object can now be in motion. That is Newton's first law. And then it has 2 parts. The other part says, so it states that an object continues in a state of rest or uniform, moving with a constant velocity. That is the second part of the definition. It says uniform or moving with a constant velocity. What does it mean? What do we mean when we say that the object is moving at a constant velocity? It means that if we now have the very same box that is moving, let's say initially this box is moving maybe at 10 meters per second. It's moving at 10 meters per second initially. Maybe the box was at this point, so that is point A, and the box once is going to move to point B. So we have point A and we have point B. So initially, let's say the box was moving at 10 meters per second, and at point B, the box is still moving at what? At 10 meters per second. If we are to have what? If we are to have point C, the box will continue to move what? At 10 meters per second. So we can see that the box is moving at a constant velocity. Constant velocity means what? If the object is moving from point A, the velocity was 10 meters per second. Then it moves to point B. The velocity of the object is still 10 meters per second. Then when it gets to point C, the velocity of the object is still at 10 meters per second. So we are saying that this object is going to continue to move with that constant velocity unless it is acted upon by a net or a resultant force. So this means that this object will continue to move at 10 meters per second unless if another force then comes and maybe pushes this box, this very same box, then the object will then change its velocity. Okay, let's move on. Then it says Newton's first law of motion is also known as the law of inertia. Then when it comes to the definition of inertia, it says you need to define inertia as the property of a body to resist any change in its state of motion or rest. So meaning if this box, the very same box, is what is at rest, this box will then resist to change its state of what? Of being at rest in this case. So this box will then resist what? To move, because it was not what? It was at rest, then it means that it is going to resist movement. And then in terms of motion, so if we have the very same box that is now in motion, it means that this box will then resist to change its state of what? Of motion, meaning the box will want to continue moving at 10 meters per second up until point D, point E, and so on. Then it says here inertia depends on the mass of an object. Okay, it says here heavier objects have greater inertia than lighter objects. So what does it mean? It means that inertia and mass are directly proportional, meaning that if you have a smaller box, so if we're speaking about the very same box, let's say that this box has a mass of 10 kilograms. If this box has a mass of 10 kilograms, it means that, and we maybe compare it with a box that has about 20 kilograms. As it says here, heavier objects have greater inertia than lighter objects. So what does this statement mean? It means that the 20 kilogram box will have a greater inertia than the 10 kilogram box. So we are then saying that the inertia is directly proportional to the mass, meaning that as the mass of the object increases, then the inertia of the object will also increase. Let me just repeat that. We are saying that inertia is directly proportional to the mass of the object, meaning that as the mass of the object increases, then the inertia of the object will also increase. Okay? Next, according to the examination guideline, we need to know how to define mass. It says mass is a measure of the inertia of a body. Okay, so we have already explained the inertia, and what we need to know, what is important, is that we need to know that mass is a scalar. So when we speak about a scalar, then what does it mean? It means that it is a physical quantity which has magnitude only. So I'm going to repeat that. A scalar is a physical quantity which has magnitude only. When we speak of magnitude, then what are we speaking about? We are speaking about the size. And what we also need to know is that mass is measured in kilograms. So let's just say that you have about 30 kilograms. Then in this case, it means that this 30 kilograms will represent your magnitude. What is magnitude? Magnitude is the size of whatever object that you have. And then this kg will then represent your what? The kg will then represent your units. Okay, so now when it comes to Newton's first law, we need to understand the following. So it says here resultant force or the net force is equals to 0. So we need to understand that F net is equals to 0. So remember I said that the Newton's first law is divided into two. Number one, number one, it is when objects are at rest. When an object is at rest, remember the illustration of the box. When objects are at rest, it means that the velocity is equals to 0 meters per second. Okay, then if the velocity is equals to 0 meters per second, then it means that its acceleration will also be equal to 0 meters per second squared. So all of this information, it comes from your formula of acceleration, which is then acceleration is the change in the velocity divided by the change in time. So when you break down the formula, it then becomes your V final minus V initial and T final minus your T initial. So just to explain this one in terms of the object at rest. So let's say that we are now going to look at the time and say, okay, maybe at time 2 seconds, what is the velocity of the object? That will then represent our initial time. And then we know that because the object is at rest, its velocity will be equal to what? It will be equal to 0. Then we are saying at time 5 seconds, what is the velocity of the very same object which is at rest? So we know that even after time 5 seconds, the velocity of the object will be 0 meters per second. Why? Because the object is at rest. There is no change in the velocity. The velocity is not increasing and the velocity is not decreasing. So what is our final velocity in this case? Our final velocity is 0 and our initial velocity is also what? Is also 0. What is our final time? We said our final time will be 5 and our initial time will be represented by what? By 2. So this then means the change in the velocity divided by the change in time. So if we have 0 minus 3 in terms of the time, then it means that our acceleration will be equal to 0 meters per second squared. So that is exactly where this acceleration is coming from. Then number 2, we have objects that are in motion. Okay, so when we have objects that are in motion, it means that that object has a certain velocity. So let's just say that as an example, we have this object here, and this object is going to move from point A. Let's say it moves from point A to point B. And then when it starts at point A, it has a velocity of 10 meters per second. Then when it gets to point B, it also has a velocity of 10 meters per second. So we are saying that this object is moving at a constant velocity. Remember, when we speak of Newton's first law, you must always remember the word constant velocity. So it's moving at a constant velocity, meaning its velocity at point A is 10 meters per second. Its velocity at point B is 10 meters per second. If we are to continue point C, point D up until point Z, its velocity will be 10 meters per second because the object is moving at a constant velocity. Okay, so if we have 10 meters per second point A, 10 meters per second point B, and let's just say that in terms of time, t initial for point A, let's say it is also 2 seconds, and then t final at point B, let's just say it is 5 seconds. Then when we calculate the acceleration, we are then going to have change in the velocity divided by the change in time. So we are then therefore going to break down the formula into Vf minus V initial and your Tf minus your T initial. So when it comes to a point B, that point B is going to represent your final. So it's going to represent your final velocity and your final time. And then point A is going to represent your initial velocity and your initial time. So if we break it down and substitute into the formula, we are then saying that our final velocity at point B is what? Is 10 meters per second. And our initial velocity at point A is also what? 10 meters per second. Okay, and when it comes to the final time, we are going to have what? 5 seconds, and the initial time is 2 seconds. So when you punch into your calculator that 10 minus 10 and you divide that by 5 minus 3, you will see that you are getting 0 meters per second. So this then takes me back to objects that are in motion. When we have objects that are in motion, we are saying, number one, the velocity is not equals to 0. Why is the velocity not equals to 0? It's because the objects are in motion. So if the objects are in motion, it means that they must be having a certain velocity. So in this case, we used what? We used the 10, and the 10 as our velocity. So it says here, objects that are in motion, they stay in motion with the same speed and direction, and with which will then give us an acceleration of 0 meters per second squared. So that is where our acceleration is coming from, and the v or the velocity is not equals to 0 is therefore explained by this example over here. Then it says use of Newton's first law of motion in everyday life. Okay, so we can use Newton's laws in terms of wearing our seat belt. That is a daily thing when it comes to, if you are going to be going in a car, then you need to put on your safety belt. Then it says, according to Newton's first law of motion, an object will continue in a state of rest or uniform motion that is constant velocity unless a non-zero net force acts upon it. So we have already discussed Newton's first law. Then it says, how does a seat belt assist in reducing serious injuries during collision? It says here, when a car collides and comes to a sudden stop, the person inside the car will continue moving forward due to inertia. This is going to take us back to Newton's first law. And what did it say? So if we are to use this as an example, then we are saying that, so if the car will be in a collision and the person is inside the car, what will happen to the person? So it means that the person inside the car, it says, will continue to move forward due to inertia. And this takes us back to Newton's first law. It says that an object, so in this case, that object is represented by what? By the person. So an object will continue in a state of, in this case, it's going to be what? In uniform motion or constant velocity. Because now in this case, the person is in motion. So if the person is in motion, then it means that we are not going to talk about the object will continue in a state of rest. Then we are going to talk about the object or the person in this case will continue to be in uniform motion or constant velocity. Then it says, without a safety belt, the person will make contact with the windscreen of the car, causing severe injuries. I mean, you can just imagine that if you are in a car and the car suddenly comes to a stop, what is expected of you? You are expected to move what? To move forward when the car comes to a stop. And you can just imagine that if you do not have a safety belt on, what does Newton's first law of motion says? It says that you will continue in that state of motion. So meaning you are going to continue and move forward up until you make contact with your windscreen. And remember, according to inertia, it says what? It says that the mass is directly proportional to the inertia. What does that mean? It means that if you have a greater mass, then your inertia will be greater. So meaning that if you are going to continue to be in a state of motion, then according to inertia, you are going to continue to be in that state of motion, and it will be hard for you to change, more harder for you to change your state of motion if you have a greater mass. Then again it says the safety belt counteracts the inertia, preventing the forward motion of the person. So meaning now that if you now have a safety belt, this safety belt then produces what? It then produces a net force. It then produces a net force. So we are saying that the safety belt will counteract the inertia. So it will resist. It is going to stop the object from moving forward. The safety belt is going to stop the person from moving onto the windscreen. Then we have acceleration. It says the rate of change of what? Of velocity. A rate of change of velocity. So immediately when we speak about the rate, then we must know that we are speaking about the change in time. So it says the rate of change of what? Rate of change is the change in time, and the velocity, which is there in terms of the formula. Then it says acceleration, like velocity, is a vector quantity. And what is a vector quantity? It is a physical a vector quantity. It is a physical quantity which has a magnitude and direction. Remember, we spoke about the magnitude. We said the magnitude is the size. So acceleration has magnitude and direction. So let's just say, for example, we have 30 meters per second squared. This 30 represents your magnitude. What is magnitude? It represents the size. And remember, we said that this one, meters per second squared, that represents your unit. So if we are then going to add maybe east or to the left, then this portion will then represent your direction. So just to repeat, acceleration is a vector quantity. So a vector quantity is a physical property which contains magnitude and direction. Magnitude is the size, and the direction will then be to the left, to the right, whether it's east or west. And then we have the SI unit of your velocity. That is in terms of the velocity. We have the SI unit of your velocity. So in terms of the formula, the change in velocity is at the top here, and the SI unit is meters per second. Then we also have the SI unit of time, which is then the formula or the symbol for time is then change in time here according to the formula, and the SI unit is seconds. Then it says, therefore, the SI unit of acceleration is meters per second squared. Okay, learners. Then we are going to do an activity. So it says here, question 2, a learner forgets his school bag on top of a vehicle. Okay, so on the picture here we have the vehicle, and then we also have the school bag. So the vehicle or the car, and also we have the school bag. So it says when the vehicle starts to move, the school bag falls off the vehicle's roof. Then it says 2.1, which term is used to explain this resistance of an object to any change in its state of motion? Let me read again. Which term is used to explain this resistance of an object to any change in its state of motion? So what is important is that we also need to focus on the mark allocation. So as we can see here, the question has a total of what? Of 1 mark. So immediately when you see this resistance of an object, then we know that we are speaking about what? Inertia. So our answer for 2.1 will then be inertia. 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 Okay, then 2.2, use Newton's first law of motion to explain why the school bag falls off the vehicle's roof and does not move with the vehicle when the vehicle starts to move. So we need to consider that initially what was happening. So initially the school bag and the car were what? They were at rest. Okay, so remember Newton's first law is divided into two. We can have objects that are at rest, or we can have objects that are in motion. So if initially the school bag and the car were at rest, it means that they will continue to be in the state of rest, right? So initially they were at the rest, the school bag and the car. That's point number one. Point number two, it means that they will then continue to be in the state of rest. Okay. Then what is the next point? The next point says that when the vehicle starts to move, the school bag falls off the vehicle's roof. So when the car then starts to move, it means that we must be having some kind of net force. Because remember, Newton's first law states that an object will continue to be at rest. So meaning the school bag and the car, they will continue to be in a state of rest unless what? Unless they are acted upon by a net force. So if initially they were in a state of rest, when the car or when the vehicle starts to move, it therefore means that we have what? We now have the net force. Okay, so it means that we have a net force that is going to be acting on the car. So that will then be our point number two. Because remember, now we have how many marks? We have a total of 3 marks. So number two, we are saying that the car then created what? A net force. Then finally, the question was saying why use Newton's first law of motion to explain why the school bag falls off the vehicle's roof and does not move with the vehicle. So the last point then, the vehicle will then continue to be in its state of rest, and that is according to Newton's first law. Okay, learners, then this is just the solution, but I've already discussed it, so I will just go through it again. 2.1, we said inertia. Then 2.2, we said initially both the car and the bag are at rest. That was your first point. Number two, the vehicle pulling away is a net force forward. That will be your second mark. And then the school bag will continue in its state of rest and therefore fall off from the rooftop. Okay, then next I'm going to give you this one so that you can try. So I will give you about 2 minutes for this one and then we can continue. Okay, welcome back, learners. And so if you have any questions, we have a WhatsApp number. So you can send your questions to 063 508 1301. I will repeat. If you have any questions, you can send them to the following WhatsApp number, 063 508 1301. Okay, so let's have a look at the question. So remember, when it comes to Newton's laws, you will find them in paper 1 and they will be under your question 2. So it says here by 2.1, the diagram below shows a box of 6 kilograms moving at a constant velocity. So this is very, very important. Moving at a constant velocity to the east. So we are also given what? Direction. Then it says while 3 forces F1, F2 and F3 are simultaneously exerted on it. So we are given the following diagram with a mass of 6 kilograms and the forces are then indicated. So we have F3 on the right hand side, we have F1 and F2 on the left hand side. Then it says the surface is frictionless. Okay, so 2.1.1, it says state Newton's first law of motion in words. So I'm sure you know Newton's first law of motion by now. And what does it say? It states that an object will continue to be at rest or in motion unless it is acted upon by a net or a resultant force. And remember, when it comes to the examination guideline, you need to state Newton's first law exactly as it is. And also we need to look at the mark allocation. So you will be given 2 marks. So remember, it will be 2 marks or nothing. You will be given 2 marks in terms of the definition. Then 2.1.2, it says what is the magnitude of the acceleration of the box? Remember, we spoke about the magnitude and we said that the magnitude represents what? The magnitude represents the size. So it says what is the magnitude of the acceleration? So if you look at the statement, you will see that it does not mention anything in terms of the acceleration. But if you read carefully and highlighted, you are going to see that they are talking about a constant velocity. So remember, we initially spoke about that and we said if we have a constant velocity, what does it mean? And I gave a scenario or an example to say that if the object is at point A, initially it has a velocity of, let's say, 10 meters per second. At point B, the object will also have a velocity of 10 meters per second. At point C, 10 meters per second, up until we get to point Z, the object has a constant velocity, meaning it has that very same 10 meters per second from point A up until what? Point Z. And remember, when we calculated the acceleration, we said in terms of this formula, we said that the final velocity from point A to point B, it therefore means it's going to be what? 10 meters per second, and the initial velocity will also be 10 meters per second. Then we also gave the time, which was about 5 seconds, and the initial time was 2 seconds. When we did the calculation, remember we said that 10 minus 10 will give us a 0, and the final time minus the initial time will give us what? 3 seconds. So when you divide a 0 with another number, it therefore gives you 0 meters per second squared. So you need to make a note that when you have a constant velocity, the acceleration will be 0 meters per second squared. I am repeating, when you are dealing with Newton's first law and you have a constant velocity, you need to remember that the acceleration will be 0 meters per second squared. So what did they ask for? They asked you for the magnitude. So the magnitude in this case will be represented by what? By 0. And then this meters per second squared will then represent your what? The unit of the acceleration. And this one here has a total of 1 mark. Okay, so I also gave you a solution for this one. 2.1.1, it says an object continues in a state of rest or uniform velocity, moving with a constant velocity unless it is acted upon by an unbalanced force or a net or a resultant force. And then 2.1.2, we said that our answer will therefore be 0. Okay, and this one, I would also like you to do this activity for me. And for this one, I will maybe give you about 5 minutes to think about this one, and we will do it together. Welcome back, learners. So just to remind you, if you have any questions, we have a WhatsApp number and you can send your questions to the following number 063-508-1301. So I will repeat, if you have any questions, we have a WhatsApp number and you can send your questions to the following number 063-508-1301. Okay, so it says here the picture below shows a young boy on a sled ride with the assistance of his older brother. Okay, then it says as the older brother applied a force of 80 Newton with his foot, so this would then represent the older brother. He's applying a force of 80 Newton with his foot. It says at an angle of 40 degrees to the horizontal, meaning that along what? Along the x-axis. It says the sled and the boy moved at a constant velocity. Remember, if we have a constant velocity, it means that the acceleration is 0 meters per second squared. So it says here, the sled and the boy moved at a constant velocity of 9 meters per second. Then it says the boy and the sled had a combined mass of 25 kilograms. So it means in this case we are speaking specifically about this boy, and this would then represent the sled of the boy. So the sled and the boy, they have a combined mass of 25 kilograms. Then it says here by 2.3, the combined mass of the boy and the sled is now increased. So we are not given the value of the new mass, but we know that the combined mass of the boy, this boy here, and the sled has now increased. Remember, initially the combined mass was what? Was 25 kilograms. But now it says the combined mass of the boy and the sled have now increased. So increase can mean anything. It can mean that it has now increased by maybe 1 kilogram, or it can mean that it has now doubled. So it can mean anything as long as there is an increase. Then it says here, while the force applied by the brother, so while the force that is applied by the brother remains constant. And what was the force of the brother? The force applied by the brother? The force applied by the brother was the 80 Newton. Then 2.3.1 says you need to define inertia, that is for 2 marks. So we spoke about this one. We said inertia, it is stated that the inertia of a body is the inertia is the property of a body to resist the change in its state of rest or in its state of motion. So remember, you need to state the definition according to the examination guidelines, and your mark allocation will also give you a guideline. Then 2.3.2 says, how will the inertia experienced by the brother be affected? So which brother? The very same brother who initially had a mass of 25 kilograms, and now the combined mass of the brother and the sled has now increased. So we are talking about that brother. So it says, how will the inertia experienced by the brother be affected? Write only increase, decrease, or remain constant, and explain your answer. So this question here has what? It has a total of 3 marks. So it means that number 1, they gave you a guideline and said you need to write only increase, decrease, or remain constant. So it means that is where you are going to start. So how are we going to explain this one, and how do we get to the increase, the decrease, or the remain constant? It means that we need to go back and use Newton's first law. We need to go back and use inertia as well as our mass. So just to repeat, how will the inertia experienced by the brother be affected? That means that you need to know the relationship between the mass and the inertia. What is the relationship between the mass and the inertia? The mass is directly proportional to the inertia. Initially, the mass of the combined mass was 25 kilograms, but now the combined mass has now increased. So if the mass has increased, what does it mean? It means that the inertia will also increase. So let's say the mass has now increased to 50 kilograms. It means that we are going to have twice as much as the inertia, twice as much as the resisting to the change, which is what? Our inertia. So number 1, how will it affect? How will the inertia experienced by the brother be affected? Number 1, the inertia is going to increase. That will be your first point. The inertia will increase. Number 2, why is the inertia increasing? The inertia will increase because the mass is directly proportional to the inertia. So remember, we had an increase in mass. So mass is directly proportional to the inertia. Then number 3, we are saying that as the mass increases, it therefore means that the inertia will increase. Okay, so here is the solution, learners, and you can just take a screenshot of the solution. Then we are going to move on to the next activity when it comes to Newton's first law. And for this one, I'm also going to give you 5 minutes to work on the solution. Welcome back, learners, and just to remind you again, if you have any questions, we have a WhatsApp number and you can send your questions to the following number 063-508-1301. Just to repeat, we have a WhatsApp number. If you have any questions, you can send your questions to the following number 063-508-1301. So 2.2 says here the photograph below shows a construction manager's car hitting a wall. Okay, then it says the car was moving at a velocity of 120 kilometers per hour during the time of the accident. Okay, so we have something here which is very important. What are we given? We are given the velocity. Then it says a passenger in the back seat who was not wearing a safety belt hit the dashboard and suffered head injuries. Okay, then 2.2.1 says which Newton's law can be used to explain what happened to the passenger. So we know that we have only learned one law so far, and that is going to be your Newton's first law. Then this is just 1 mark, so you just need to state or you need to write that it is Newton's first law. 2.2.2 has an allocation of 2 marks. Then it says that you need to state the law mentioned in question 2.2.1 in words. So I'm sure that by now you master the definition in terms of Newton's first law. And what does it say? It states that when an object is in motion, or when an object is at rest, it will continue to be in a state of rest, or it will continue to be in motion unless if we have a net force that is going to act where? That is going to act on that object. Okay, so again, as a reminder, you need to state the definition according to the examination guidelines. Then 2.2.3 has an allocation of 3 marks. It says here, use the law stated above. So you already know that that law, where did you state it? You stated it here by 2.2.2, and that law is what is your Newton's first law. We stated the law. So it says use the law stated above to explain what happened to the passenger. Okay, so we just need to state what we know according to Newton's first law. So remember, we were given a velocity of what? We were given a velocity of 120 kilometers per hour. Okay, so we need to explain what happened to the passenger. The passenger was in the vehicle, so it means that the passenger was also moving at a velocity of 120 kilometers per hour. So remember, in terms of Newton's law, we have 2 things. We have objects that are at rest, and we also have objects that are in what? That are in motion. So in this case, the passenger was inside the vehicle, or the passenger was inside the car. The car was moving at a velocity of 120 kilometers per hour. That also means that the passenger was also moving at a velocity of what? At a velocity of the very same 120 kilometers per hour. So a very important thing here, it says that this passenger was not wearing a safety belt and therefore hit the dashboard and suffered head injuries. So according to Newton's first law, if an object is in motion, it will continue to be in motion at that constant velocity, right? So it means that this passenger was in motion, number one, and it therefore means that the passenger, it therefore means that when the car hits the wall, the passenger will continue to be in motion at what velocity? At 120 kilometers per hour, right? So as the passenger continues to be in motion at 1 kilometers per hour, and the passenger is not wearing a safety belt, and according to the mass of the passenger will then what? Will then move forward. That is according to Newton's first law. The passenger will then move forward, therefore doing what? Hitting the dashboard. So what does it mean? It means that as the car hit the wall, the car then created a net force. Okay, so the passenger and the car were moving at a constant velocity. So when the car hit the wall, it created a net force. So when that net force was then created, it caused what? It caused the passenger to move forward and therefore hit the dashboard. Okay, so here are the solutions, and you can just take a screenshot of the solutions. Next we have the normal force. So the normal force is represented by the capital letter N, and then it says the perpendicular force exerted by a surface on an object that lies on that object. So when it comes to the normal force, you need to be able to explain the definition according to your examination guidelines, and you need to be able to use the following scenarios. Okay, number one, when it comes to the net force, we have the net force on a horizontal surface. So you would then be representing the net force in this way. So it will be an arrow facing where? Upwards, because it says the perpendicular force exerted by a surface on an object. So perpendicular force meaning if this is your surface, then the force should be perpendicular to the surface. Then number two, when it comes to the normal force, we have what we call a pulling force. So you should be able to represent the normal force in this way as well. So this would then represent your applied force. Then scenario number three, it is when we have your pushing force. So you should be able to represent the normal force again in this way, and this would then represent your pushing force. So this would then represent your applied force. Then we have your weight, which is W, or it can also be represented by FG. You need to state it according to the examination guidelines, and it says the gravitational force that the Earth exerts on any object on or near its surface. So again, using the very same diagrams, you need to be able to represent your weight or your gravitational force. So using the very same diagrams, this would then represent your weight or your gravitational force. Weight or your gravitational force. Okay. Then again we have the frictional force, and then it says the force that is parallel to the surface that opposes the motion of the object, and that frictional force can be represented by a small letter F, or you can also represent it by a capital letter F and also a small letter F. So what you need to know is that we have two types of frictions. Number one, we have your kinetic friction, which is then the frictional force that acts between the two surfaces when the object is in motion. So the kinetic friction, it is when we are speaking about objects that are in motion. And the kinetic friction can be represented by a small letter F and a small letter K there. And then we also have our static friction. And then it says that frictional force that acts between the two surfaces when the object is stationary. So when we speak of the static friction, then we are speaking about friction and objects which are not in motion. So when it comes to friction, you need to know how to represent friction. So if this is your object, it says it is the force that is parallel to the surface. So very important. Force that is parallel to the surface. So if this is your surface, then it means that the friction will be represented here because it must be parallel to the surface. And then it says that opposes the motion of the object. So meaning, if for example the object is being pulled to the right, it opposes the motion of the object. So meaning it will be in the opposite direction of motion. So if the object is moving to the right this way, it's moving to the right in that direction, then friction will then oppose the motion. Then when it comes to friction, the kinetic friction, we have, for the formula of the kinetic friction, we have Fk, which is then equals to mu k multiplied by the normal force. Then for the static friction, we have Fs, which is then equals to mu s, which is the coefficient of static friction, multiplied by the normal force. So this one would represent the static friction, this one represents the coefficient of static friction, and this one represents what? The normal force. So just to go back to this one represents the kinetic friction, this one represents the coefficient of kinetic friction, and this one will represent your normal force. Okay, learners, we are going to take a 1 minute break.
Excellent. Excellence is a habit. Excellence is a quality you have, a quality I have. It's a quality we have when we honor what is true to us. Yes, we are gifted differently. uNkulunkulu akasinganga ngokufana. Excellence is striving for your best. Whenever you have a particular project, test, homework, uzibuze, ask yourself, is this my best? Can I put in more effort? Excellence is striving to be in the top 1% of the area in which you are gifted. And so I challenge you, in every single thing that you do, in every single area that you're gifted in, whether it's sports, it's academic, ucula, whatever that gift is, strive for excellence.
Welcome back, learners. So we are going to continue from here. And then next we have your tension, which can be represented by capital letter T. And then it says here, it is a force acting on a string or a rope. So we are going to get into detail as we continue with this chapter. Next, we have your force and your free body diagram. So it says here, an object is pulled by a constant force F on a horizontal rough surface to the right. So when we speak about a horizontal rough surface, we immediately know that there is friction that is involved. So number one, an object is pulled by a constant force F. And it is pulled in which direction? The object is pulled to the right. But this object is on a horizontal rough surface. Then we immediately know that they are talking about what? The friction. Then it says here, draw a labeled force and free body diagram indicating all the forces acting on the object. So we have on this side a force diagram which is represented by a box. And in this box, we have the normal force, which is then going upwards. On the right-hand side, we have the applied force. And on the left-hand side, which is in the opposite direction of motion, we have the frictional force. And then at the bottom, we have the weight or the gravitational force. So on the right hand side, I'm saying we have the applied force, but in the opposite direction of motion. Remember, that is our friction. It acts in the opposite direction of motion. So therefore, our friction will be where? It will be on the left hand side. So according to the examination guidelines, you need to know how to draw the force diagram, and you also need to know how to draw the free body diagram. So now you need to know how to represent this box in terms of what? By using a dot. So when it comes to the free body diagram, instead of you using a box, you are now just going to use what? You are now going to be using the dot. Okay, you are now going to be using the dot. Okay, so we have again we have the normal force, which is represented on both sides. And then to the right hand side, what do we have? We have the applied force, and to the left hand side we have the frictional force, and downwards we have the gravitational force that is represented here. Then with another scenario, you are given what? You are given two boxes. So you have box A, and you also have what? You also have box B. And we can see that between box A and box B, by box A, we have F. What does F represent? It represents the applied force. But in between the two boxes, we can see that we have tension, right? So you need to know how to draw the force diagram. So the force diagram is represented here. We are always going to have what? The normal force and the gravitational force. But to the right, what do we have represented there? We have the tension that is represented on our right hand side. Why do we have tension? Because we have a rope on the right hand side of a box A. And then again, we also have friction that is acting against what? Motion, or that is acting in the opposite direction of what? Of motion. So if the object is being pulled to the right, then our friction will be where? Opposite direction of motion. So it means for box A, our friction will be represented where? On the left hand side. And then for box B, we can see that we have an applied force. So with that applied force, it will be indicated on the right hand side. And then again for box B, we are going to have a representation of the normal force, the gravitational force, and what do we see on the left hand side? We see that we have our tension. Why do we have tension on the left hand side? It is because we have a rope. Okay, again by box B, we also have our friction. So if the object or box B is being pulled to the right hand side, then the friction will be in the opposite direction of motion. So that is why the friction is represented where? On the left hand side. So if you are to represent this using a free body diagram, then you would represent it in the following way. So what is important then is that you are going to start by drawing a dot, and then you will then have your normal force. At the bottom, you are going to have your gravitational force. So I'm representing box A. Then to the right hand side, you are then going to have a representation of the tension. Then on the left, you are going to represent your friction. Then for box B, looking at the force diagram, what are we going to have? So we are going to have the following. On box B, we are also going to have the normal force. At the bottom, we are going to have the gravitational force. Then to the right, we can see that we have what? We have the applied force. To the left, what is it that we have? We have our tension, which can be represented by capital letter T, or it can also be represented by capital letter F and capital letter T, small capital letter T at the bottom. Then we also have our friction here. That is according to the force diagram. So for box A, we can see that we are going to have a total of how many forces? We are going to have the normal force, we are going to have tension, the gravitational force, and the frictional force. Then for box B, how many forces are we going to have? We see that according to the free body diagram and the force diagram, we have our normal force, which is 1, applied force, which is 2, gravitational force, which is 3, frictional force, which is 4, and then we also have our tension, which is then a total of how many? 5 forces. Okay, so thank you very much, learners. And we are going to end today's lesson with a quote from Nelson Mandela, and it says, "It is in your hands to create a better world for all who live in it." So I will see you next time, that is next week, and at the very same time. Thank you so much.